I'm Swiz, and right, so right now I work for a biotech startup where we build some cool stuff for people who program with DNA. But today I want to talk to you about web rendering shenanigans, and we're going to use rewrites as the excuse to talk about it. So, what does everyone do when they first walk into a new code base? It's shit, right? It sucks. It's not even using full stack JavaScript. There's a bunch of jQuery everywhere. There's no API. Everything triggers a slow reload. All of that stuff. Like literally every new engineer that comes into your code probably says, "This is crap. Let's rewrite it. We got to go from scratch." Now here's the secret of the dirty little secret of the software engineering industry is that everyone is always rewriting. When your company is growing quickly or changing quickly, things change. You can't predict the future. You can't really, you don't really know what you're going to need in 6 months, in 3 months. The stuff that worked yesterday is not going to work tomorrow. And production software is just trash. That's how it is. Reality is hard, and every tutorial you ever read was more or less lying to you. It's not that easy. So, the really good companies aren't the ones who build rock-solid systems that last forever. They're the companies that learn how to change the fastest. I actually stole this from a Will Larson book, if anyone knows who that is. He says that when he was at Stripe, he learned that you're always mid-rewrite, you're always mid-change from the old system to the new system, so the better you get at those transitions, the easier your life is going to be and the faster you can adapt to the industry or whatever. Stuff changes. So today, we're going to talk a little bit about how you would actually do that. Your code, how your code looks doesn't actually matter, but your architecture and your code structure really does. And we're not writing poetry. We're writing a 12-book epic saga, unlike George Martin, who is running around not finishing his thing. So we're, what was I going to say? Yeah, so the real problem with Jinja or jQuery spaghetti or Ruby on Rails spaghetti or like monster pages that try to do everything is that they're not structured, and it makes it really hard to adapt. So the component model won for a reason. We want components because it gives us isolated bits of code that are easy to swap in and out and replace. So the first way you can rewrite stuff is using React islands. So here is an example of 2 tiny React apps running side by side. I literally coded this morning because it turns out StackBlitz doesn't work on an iPad. So it's really hard to do on a plane. So this is 2 tiny React apps. Each of these squares is a full React app. It renders from scratch. It has its own React query. It brings its own styling. And I'm using a very slow random number generator with a timeout to mimic an API query. So when you click regenerate, so when the islands first load on the page, it makes an API request, shows some data. It gets props from when it's being called as a function, renders that. So that's how you can see that these are 2 different apps. And the rest of the page is just plain old static HTML. So if you're paying attention, you'll notice that whichever regenerate I click, it updates both islands to the same number. That's because even though they're separate React apps, they're actually sharing the same React query instance, or the same React query client instance, which means they can share memory. They have access to the same bit of memory in your JavaScript, and they can communicate that way. I haven't tested it, but this should work with any global state management thing that you use. So it should work with Xstate, it should work with Redux, anything that has an external store that it connects to. So, so more or less, this is pretty standard SPA stuff. We have some HTML. If you've ever looked at Create React app or any of those, usually they give you a div with an empty page, and then you take over the whole page and you build everything with JavaScript. In this case, we have a bunch of existing HTML that we can keep using. So we have, you can't really see that very well. But at the bottom of that is essentially we have a example island function call that takes a DOM element and some props, and then it renders into the page. And I can actually show you, let's see, let's try showing you a bit more code than that. Oops, that's from the future. Let's see. So I can't run this on my iPad, but I can show you the code. So let's see if I zoom in, can you see that? You cannot even see that. Never mind then. That's going to make demos much harder. What do I have to press? Well. Okay, I should have done more tech check. How do you tell an iPad to share the whole screen? You don't. Add another one. Oh, move to display. Cool. Okay, so I can do that. iOS, magic. But now I can't see what I'm doing. Okay, so I'm going to turn around. So basically, you have a... so example island is a function, takes an element, takes some props, and then it creates a new root, a new React root if it doesn't exist, renders an island wrapper, and then an example. The example component is pretty much standard React. It uses a query, it renders some stuff using, I'm using a MUI-based framework that uses Motion, CSS, JS stuff. Nothing super interesting there. But it can render static props that come from the server. Now, this is a way that you can communicate from your old code to your React islands. And then it has the standard thing to run a React query. So that is all fun and good. Now what happens if I click this? Okay, so basically you can build these highly interactive components and move them around. And because you have a shared query client, all of the islands on your page have a shared memory. So even if they run the same API requests, or if the API requests are invalidating, everything works the same as if it was an SPA. The other nice thing is that you can keep using your old or whatever existing routing infrastructure you had. It's essentially a multi-page app. I think we used to just call them a regular web page. Now it's a multi-page app, but it's basically if you click a link, it's going to reload and you're going to get more islands, or you can navigate within the island. Cool. So that gives you the ability to build modern JavaScript-based islands of high interactivity. Now, and you can do form submits, because I think a lot of engineers forget this, but if you wrap a React component in a regular form and then render input elements, you can submit to your same old form endpoints. Just do a submit event. And this actually works. We use this in production. You wrap a React island in a form and it works. So this gives you the ability to have highly interactive islands inside your normal HTML app. But what about the other way? What about all the code that you already have working in HTML, in old HTML and jQuery? How can you get that into React? My idea for this was to essentially abuse React server components, and that's what this talk was originally going to be about. I couldn't get this to work. So the idea of React server components is very similar to if you've ever used Hotwire in Ruby on Rails, or Next.js is also based a lot on this stuff. But it's basically you have a React component on the left, you click a button, it makes an API request, and that API request returns a React component, and then React replaces part of your component tree with that new component. Dan Abramov calls this React for two computers, and it's essentially a way to swap, to render things on the server and then swap them into your UI. I couldn't get this to work because we don't have a JavaScript backend, so we use Python. So in the Python world, React is not very well supported. However, this one of the big comments people make on this is, wait, doesn't that couple your front end and your back end? Yes, it does. And long term, if you've ever worked in industry for a few years, you've probably noticed that the client and server never stay decoupled for very long. If you're writing full stack apps and you're doing server code, unless you have more than one client at the time of writing your API, you are almost guaranteed to write an API specific for what you're doing on the client that day. So React server components and and a lot of the modern front-end tooling is like, fuck it, let's just say they're coupled and build and like, let's not kid ourselves that we're not coupling these things. So I couldn't figure out how to do the thing with React server components, but luckily in the Python world or in the hypermedia world, you have HTMX. So here is, yeah, exactly. HTMX is actually really cool. There was somebody was joking on I think on Hacker News that the X in HTMX stands for JSX, and the inventor of HTMX was just like, yes, that is the same thing. HTMX and React server components and Hotwire and probably some others, they're all the same thing. So here's an ugly UI that I built with HTMX. It's basically a little admin tool to manage inviting users to a lab. Doesn't matter what that means, but what matters is that I could do this, make it more interactive than it was before. There's no full page reload. When I add a person, it just shows up on the page. When I click delete, it asks for a confirmation and it goes away. No page reloads. Everything's happening in JavaScript. But I didn't actually have to write almost any JavaScript. I just did this. So what is this? This is this is basically the same code that we had before. I didn't need to change the backend almost at all. And it's doing a very SPA thing. You have a div that loads, that triggers on load. So you have a div that gets its contents from a get API using URL4. It renders itself by replacing the inner HTML of a div. This is very similar to injecting a React island. And the loading triggers when, the get request triggers when you load the page or when you trigger a user's updated event from the body. And then the form below it that actually does the work is just form with the method post, and then instead of action, you write xhpost, which is like an HTMX syntax thingy, and now this form can submit to a post to a server. The server responds with some, in this case, it responds with the HTML for the success message, and a header to trigger the user's updated event, and then the browser makes a request to the server, re-renders the whole list of users, and shows it again. Very little JavaScript, basically no rewriting on the server, the same old stuff that renders HTML and some jQuery works as before. And then another nice thing about HTMX is that you can do these xhpost and etc. Requests on any element. So here we have the the delete button, where if you look over here, I'm just adding when you click on this button, issue a delete request to the server, let the server do whatever, and then ask for a confirmation before you do that. So that's nice. We can now build somewhat interactive UIs without rewriting all of our server stuff and all of our server-side rendering that was built in ancient technologies from like almost 5 years ago. So this is cool. It means that you can move quickly, build these semi-interactive things, but you don't have to rewrite everything. So the ultimate dream that I have is, what if you could write the same components as you do? So what if you could write a component and it then behaves correctly, whether it's rendering on the server, rendering in the browser, maybe rendering as an image, and And your product engineers don't have to think about what they're actually doing. They're just writing React components, the same as any tutorial tells them, the same as they learn in a boot camp, the same as they learn in documentation, or even whatever an LLM would spit out when they're using Cursor. But then the framework figures out what to do with that. So we're gonna, so the way I got that working is TanStack Start. Tanner did all of the hard work for me. I've just been playing around with it. And it's actually cool timing because they just released a V1 candidate. On Tuesday. So I've been playing around with it since like March or something. It's really good. You should go try it out. I'm excited to play with V1. But today I wanted to show you a couple of demos of what we built with TanStack Start and React Islands. So let's see, what do I need to do to make this work? So I switch to Safari, and then Safari is over there. And then I go to, not this one, this demo. All right, so nope. Move to display. Okay, now you can see it. So this demo is where's my mouse? Okay, so this demo is, this is something we've built at Plasmidsaurus. This is a DNA visualization for biotech researchers. I don't fully understand how it works, but the kebabs on a string represent features in DNA of some engineered organisms, and researchers look at this and they know what it means, and they're like, "Oh, cool!" It's essentially like looking at a diff of your code on Git, and a normal person looks at it and is like, "This is meaningless." But when you look at it, you say, "Oh yeah, this function does a thing, that function does another thing. This is similar. All of these shapes mean something to biotech." So if I reload this page, you see the HTML loaded first. Most of the header is in HTML. Everything else is in SPA. And then we download on the client. You'll see there's a loading state that's downloading DNA from S3, and then it's visualizing the DNA in the browser using SVG. And now I know this isn't impressive if you haven't done it before, but it's actually pretty interesting because each of these visualizations represents a couple 100,000 data points, and JavaScript is parsing it all, figuring out what it means, and then displaying it. And then if you mouse over it, you get some nice, what is this? You get feature names, which I'm told are super meaningful. And then if you scroll down, you can see more detailed, if you remember from, so you can zoom, the bottom is an entire DNA sequence of a simple organism. And then you can see so here you can see that this researcher, they tried to build the bottom DNA, but they got the top DNA and they're slightly different. So this diff is showing them there's a problem. And then we have some highlights. You can mouse over this and it tells you what's going on. So that's all pretty fun. Now, this all happened in the browser. Now, let's see, how do I change to a different tab? Now, you can just move that same component into TanStack Start. So here I have TanStack Start running on a Lambda. And when I reload this page, you'll notice that the initial load is all there. There's no loading state in the browser. It's just it's actually returning plain old HTML. I don't know how to do it in Safari, but if I turned off my JavaScript, this would still load and I would still see what's going on. And then once it's loaded, it hydrates, which means it becomes interactive. React runs over it and does its thing. And then I can mouse over and everything works the same as before. I can go down here, I can click on these things, and basically I can see the same differences in DNA. Now, and another cool thing I can do is I can then go and I can say format PNG, and let's say we want a an image that is 1024 pixels wide and let's say 600 pixels tall. Let's see if this works. Oh, I made a typo there. So what I'm expecting here is to get these same components, the same UI, but as an image in one request. So not just in one request response cycle, I should get back a PNG, and I did. So this looks the same as before, but I can actually go save to photos, and I don't know where that showed up, but it's an image, it downloaded as an image. And the way this works is that it's server-side rendered the whole UI using the same components, and then started up a Puppeteer, took a screenshot of it, and returned that as the response of my server-side rendering. So instead of returning HTML, it just returns a straight-up PNG. We're getting short on time. So the way that, okay, we can skip this. This is a GIF showing you kind of what's going on. But the magic that made this possible is that with TanStack Start, you can have a shared query cache between the client and the server. So on the server, so when you hit the Lambda runs a Node.js server, renders all of the React in memory. Actually, it runs a Node.js server. The server then makes an API request to our Python server to fetch the data, fetch the DNA data, analyze it, so fetch the DNA data, returns it, then renders it using React, returns the HTML, and then returns the HTML and returns some pre-populated query caches. So then when the same component runs on the server, on the client, that component already has the query cache populated, and it's like, cool, I don't need to load this again, so you don't get the loading spinners. The basic code for how this works is I have a server function. This function, no matter where I call it from in my JavaScript code, will always run on the inside the Node.js server, which means I can safely use process env vars, so I can safely use API tokens. I'm not going to leak any secrets to the client, and it's making these requests these will never leak to the client. And then in a route, this is where you define the actual URL where all of this happens. You have a component which I'm not showing here, and then the route loader basically says when you come to this URL, whether you're a server or you're a client, fetch the data, and then in this case, I'm populating it into the query client, which then gets propagated to the browser where it doesn't need to make another API request. So this is where I feel like whenever I try to explain this, I look like that crazy guy from Always Sunny in Philadelphia with my whiteboard. But it's really cool. The loader, coupling the loader to your router makes it really easy to coordinate queries, and then you can write a bunch of actual UI components without worrying about how loading works and whether they're on the server or not. So hopefully this convinced you to give TanStack Start a try. We had an excuse to talk about some rewrite shenanigans and some how modern web rendering works. You can use this QR code to sign up to my newsletter, download slides, all of that good stuff, and you can find me on the internet as Swizec. Thank you.